Well, we can now start with the tutorial part of the, and then the tutorial is Mac OS X. We have only tested on Mac OS X, so it should work on Linux too. Programming language we'll be using Scala, but the code samples we'll be providing. So if you don't know Scala, that's fine. We'll go through it, and we are using Kafka and Spark to demonstrate the samples. And we are distributing the USB sticks to all the people, so you can download the software from USB stick. Yeah, copy the software from the USB stick. And basically, there's only one folder on USB stick, KDD stream tutorial. Just copy that to your home folder. And make sure Java is installed and working on your laptops. And you can do Java minus version and it will show you. And another thing which we'll need is Maven. Maven is the Java and Scala build tool. So while we are So while we are copying the code and the folder onto your, we can go over the tutorial, describe the tutorial to you. So we'll be doing two tutorials. The first one is live wiki edit events. So we'll be capturing the live edits to Wikipedia English and from the Wikipedia IRC server, and then writing them onto the Kafka topic. And from the Kafka topic, a Spark streaming consumer will be reading it and doing some calculating some metrics like how many of the edits are from bots and how many of the edits are from the humans. So that is the first tutorial. And the second tutorial, we will have two different producers, add and click producers. Basically, the data is in the files already. We'll be reading the data from the fly files, writing them to the Kafka topics, and then from Kafka topics there will be again a Spark streaming consumer reading it, joining those two streams, and then doing aggregations and using state to do aggregation, accumulation of the. One of the couple of concepts of Spark that, even though this tutorial is not very Spark specific, it's in general streaming, but since we are using Spark, there are a couple of concepts of Spark that is good to know for this tutorial. One is the RDD, which is resilient distributed data set, which Spark has. So basically, the collection whenever Sparks reads any data, it basically stores into RDDs and splits the data across the various nodes using RDDs. One of the important things in RDDs is that RDD stores the lineage. Basically, it knows how that RDD was formed, what kind of operations took place to build that RDD. And in case of a crash or a failure, the Spark can rebuild that RDD based on that lineage data. But for now, we can just, for this case study, we can just assume it to be a collection of objects. Spark streaming, on the other hand, adds another collection over the RDDs. It's called dstream. Since Spark is a mini batch system, there are various, as the data arrives, the events arrives, it groups them into batches and makes a RDD out of each batch. Now those collection of RDDs is called a dstream. So dstream is another object that we'll be using. So dstream is just a collection of RDDs, and RDD is the collection of messages for that specific mini batch or window. So once you have copied that, how many people have already copied? Okay, so once you have copied that, you will see there are multiple things inside it. One is the folder called inside the KDD stream tutorial. There's a streaming tutorial folder, and then that is where all the code is. And then there's also Spark Streaming, Kafka, and Scala inside that folder. So only thing you need to have on your laptop other than that is basically make sure that Java is running and Maven. You have a Maven installed. Does everybody have Java and Maven? No, pretty much. So hash. No, it's a collection. I mean, from the user perspective, it's a totally different thing. For if you want to read how the details of RDD works, then the best, I think, source is to read the Matai Zaveri's paper on RDD. Exactly. So that is probably the most authoritative paper on how the RDDs work. So I will, yeah. Yeah. So I can now walk through the Wikipedia connector code. We will not be making any changes to it. It is the code which actually connects to the IRC stream in real time, IRC stream from Wikipedia, and then listens to all the edits and then writes them to the Kafka. So if you see what we are doing is we are creating a Kafka producer, and I will go into detail on how we do create a Kafka producer, get IRC connection to the Wikipedia IRC, join that connection for the Wikipedia English, and then just run it. And while doing it, we are providing it with a listener object. So this is the code to connect IRC, do IRC connection, and I'm using basically an open source library to do IRC connection. And we are specifying the ircwikimedia.org is the host and the port. And this is the listener object, Wikipedia IRC channel listener, which is the one which is basically receiving all the events and then writing it to the Kafka. Here is the Kafka producer. This is the software which actually creates a connection to, this is the part which creates a connection to the Kafka. So since we will be running Kafka on our own server and a single server Kafka, it is localhost 1992 and various standard parameters. Both key and value needs to give in a serializer. And here we are just using simple strings, otherwise we can use Avro. And this is the part of the listener code, listener object, which we had registered with the IRC connection object. And this listener code, basically whenever there's an edit event on Wikipedia IRC and it is published to the IRC channel, this get executed on-prem message and it receives the message. And then we are printing the message as well as this producer.sends sends it to Kafka. And these are the various other events which IRC system generates, but we are not interested or listening to them. So this is the simple Wikipedia connector program, which basically creates a connection to IRC channel, listen to the event, and when it receives the event, it sends it to the Kafka.
So it's that
Yes, that's the thing which is actually doing all the connection to the IRC and calling the method on the registered listener object. And this is the open source library that I am using. It's org.shevring.irc.lib. If you look into the import statements, you will see which library. And you can also check it in the POM also. And if for the people who are not aware, familiar with if Maven, POM is the file where we specify all the dependencies. This is not something you will need for tutorial, but just a FYI kind of thing. So now it's pretty much everybody copied the folders. Okay, so this is something we can now start with. So you have to open up a terminal window on Mac, and there's actually a PDF of this tutorial slides distributed, so you can just copy paste the command from there. It's inside the folder. That will be save time from typing. Yes. Okay. Yeah, these are just the I think standard properties we took from somewhere. Yeah. Just look. Even I have to check. I'm not too sure. But I used it for a long time. Um, So how many people have Kafka running? I think it's the time we should. Oh, you will need that laptop to run.
So is everybody ready with the environment? Zookeeper running, Kafka server running? Okay, good. So we can move on to the next step. So we want to check our Wikipedia edit stream and look at the messages that we are receiving. So follow these steps. So in a new terminal window, we go to streaming tutorial directory. And copy it and paste the next command. So we are still waiting for Wikipedia stream. You can also use your okay. So there seems to be some problem. Wikipedia connector. So we build a package. The stream is not working. Connection failed, operation timer. It's already packaged, right? It's built. Yeah.
Your internet connection is fine, right?
Yeah, I think.
Yeah, are you connected to? Maybe you should try to connect to KDD. Connected to. Yeah, not right.
Okay.
Working.
So we are receiving Wikipedia edit stream now, and you can see that the events are coming in. Now we'll look at the event. What does it mean? So the events look like this. There are 3 events here. So there is title part of it. There are 6 fields. So first part is title. Then second is some flags, and those flags can be minor, new, unpatrolled, bot edit. So B represents bot edit and everything else represents human edit. The next one is the URL, the difference where the differences are recorded, and then the user, the difference of bytes, and then summary. So as you can see out of these 3 records, when we want to our program should capture these 2 events which are edited by bot and do counting on those. This is the pattern we are going to use. So now we want to, we can stop this stream and look at and do coding in our program, and then we'll run it. So you guys open this file in your favorite editor, streaming tutorial. I think mine is, this is my old copy in my personal laptop. So let me try.
Also, there is a full code folder inside the streaming, and the full code has the complete code, while the code in the source folder is the one without the where you have to put in the real code.
I already have an old copy of that.
Okay, so this is the file we'll be changing, Wikipedia streaming.scala, and if you read through this, is basically we are creating a Spark config, we are creating a Spark context, which is the entryway to Spark system, and then we are creating a streaming context, and that is the one which we'll be using to do all the operations and everything. So from streaming context, if you see, this line is just a regex pattern for the message. Here we are providing it with the Kafka topic, which is my topic. That's the topic which the Wikipedia connector is writing to. And this is the, here if you, next is of course some Kafka PALM where to connect to. And this is the important part, Kafka util.create direct stream. This is a utility provided by Spark, which is a Kafka connector. And if you provide the topic name and the host and port for the Kafka, it can directly create a connection, streaming connection from Spark streaming to Kafka for you. And so you just have to pass the streaming context, Kafka PALMs, and the topic name. And then it will generate something called messages. Messages dstream. Like I explained earlier, dstream is a collection of RDDs, which in turn each RDD is a collection of messages. And then for on that messages, which is a dstream, a collection of RDD, will do for each RDD. That means all the operations we apply inside these curly brackets are applied on the each RDD inside the dstream. So that's why we have got this RDD. And if you're not familiar with the Scala, this is just like a lambda expression. I mean, basically you take RDD and then you apply operations on that RDD. So each line of that RDD, oh sorry, each RDD of that dstream. And then you can apply operations. And if you can look at the code, let us go to the full code. We have got in the full code, we have full code here. So what are the operations we want to do on that RDD? Let us say, first we will create something called a data frame by extracting fields from the Wikipedia messages. So here we are applying, and this is pretty Scala specific code, that you are taking RDD now, applying another map function. Map takes each line and then do some transformation over it, right, to line by line in the RDD. So we take each row. On that row, we take the second part of the row, because the first part of the row, the first value in the row is a key. The row is a key value pair. So we ignore the key and we take the value. So this underscore 2 says 6, take the second part of the tuple. And then you match it to the pattern. So second part of that message is actually the message we got from Wikipedia. First one is key, which we don't care about. And then we apply the pattern and we generate an object. And then if the message doesn't match that pattern, we want to ignore it. So we filter that out. And then we convert it into a data frame. Yeah, so that is what we are doing here with this case pattern and case underscore. So if it matches the pattern, then we get a good object. If it doesn't match the pattern, then we get we have just created a dummy object for now, which is these fields, title, flag and all. And then in the next step, we just filters all the rows where the title, so that we only get the good rows. And then we just convert it into another Spark object, which is called a data frame. And then all the other operations we will do is on the data frame. And then we can do count on data frame, filter, and then calculate how many are the bots. So this gives you bots, not bot, which is human. And then we are printing those. And this in the line in the end is actually the one which is starting the whole listening process, all basically the Spark consumer on Kafka, which is listening and then running. So you can copy this code into your line, or we can just go ahead and run it. So let me see. It was just for demo purposes that it looks good. We don't want to wait 30 seconds, but we can easily, there's a line here, you can run it with 30 seconds. If you see messages dot for each RDD, before this is a line, message dot window commented dot line seconds 30 seconds 10. That's, yeah. No. Yeah. Yeah. Because it's a many batch system, yes, so we have to. So there's only one D stream, but the RDDs will be created every 10 seconds. So RDD is a collection of messages. Think them as mini batches. So every 10 seconds it will create a mini batch of all the messages received in those 10 seconds. And then it will give it to you to process. Yes. So D stream, think of it as like a parent object which is a collection of, yeah, which has got all the RDDs. RDDs are coming in and going out. Yes. 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 And you can always, yes. Here we have got given a fixed window of 10 seconds, a mini batch of 10 seconds, but you can always have like sliding window. Like this line particular window, 30 seconds and 10 seconds. And you can always change those things till it is a multiple of the first batch you specified. So you can later on change the window size till that window size is multiple of the original size you specified here. It can always aggregate those RDDs into a bigger batch. Yes. In the next tutorial, we will see if we want to go across batches and do a cumulative count by using state. Yeah, code is already USB. Yeah. Oh, we can. I can give you some USB. Okay. Oh, he already has one. Yeah, he got one. Instead of, I mean, you can try typing the whole code, but once you have added those lines, you can start a new window and go into that folder streaming tutorial and do Maven MVN package to rebuild the package. Okay, Zookeeper is part of Kafka. So Kafka is using so this question is that how is Zookeeper, Kafka, and Wikipedia connector related? Zookeeper is part of Kafka. Kafka is using it. We are not using it directly in our tutorial at all. Zookeeper. So Kafka uses it to keep its state and its offsets and all consumer offsets are kept in Zookeeper. Kafka uses it internally. Yes, offsets, consumer offsets, and things like that. Yes.
The Kafka server needs to be running to access this.
No, so Kafka server, okay, so the way it is working is that Wikipedia connector is connecting to the IRC server, Wikipedia IRC server, listening to the edits, and then writing it to Kafka. So if you go into the Wikipedia connector code, there's a producer.send message line. That producer.send is Kafka producer.send, send the message to the Kafka producer with the topic name, my topic. So it will write that particular message it has received from Wikipedia IRC channel to that topic. Once the message is being written into the Kafka topic, and Kafka topic you can specify retention like 1 day, 24 hours, 48 hours, or on based on size. So the message will remain in the. So now when the Spark streaming starts, it will start reading those messages from the last offset from Kafka. Think of Kafka just as a log file or a queue. Think of it as a queue. You're rewriting at one end, reading from another end. It's totally ordered within a partition. Here we are using just one partition for simplicity. And then, so Spark streaming will start reading from the last offset. So that offset Kafka keeps in Zookeeper. And of course, it keeps other information about his nodes and various things into Zookeeper. The way the Spark streaming connector has changed now is that instead of using the Kafka Zookeeper as to keep offset, they have started keeping offset with themselves to provide a proper transaction, because now they will had to otherwise include Zookeeper as part of the transaction, which was hard. right? So that's the change they have done. So Spark connector maintains the offsets. Spark connector maintains the offset itself now in the latest changes they have done.
Which key edits were getting at very topic, but I think this is really quick. Different sorts of Kafka servers that are for free jobs and that.
Yes. You can create any topic, and actually even if the topic is not created in Kafka, first time you do a write to Kafka with a topic name, it will create a topic for you, and you can write any kind of message till you have the right serializers defined for it. Right now we have string, but like LinkedIn we use Avro, but you can easily use Protobuf or any other. So, yeah. So has everybody able to compile, build the Maven, reach this stage, Maven package? How many? Okay. So then next is just to, in the terminal window, run Wikipedia connector. So if you are struggling or have any questions, just raise your hands and one of us will come to you. Yes.
I think the name of the body is different.
Name of the,
Slide 12.
this one or next?
Slide 12. Because it's slide 12. What? What? Yeah, the one. It says like the volume, like line 3F, right? But isn't it supposed to be Wikipedia?
Wiki.
Wikipedia. So if you go to the next slide, so you're referring that volume as a Wikipedia.
Oh, wiki edit. Yeah.
No. Line 3F.
Yes.
I think that name is supposed to be Wikipedia.
Oh, really? Okay.
You go down.
We're using lines TF.
Yeah, and then if you go to slide, the slide number 13, if you go next slide. Yeah.
Oh, okay. Yes. Yes. So we this. Yeah, slide is old. Yeah, slide is not been.
That probably could
Yes. Slide I think is.
And also there's no print statement of line, so you take the code from the
Full code, yes. Yeah, it doesn't show the print statement, so you don't need to take the code from the full code, yes. And just run this, and then the next, first run this Wikipedia connector, and then next terminal window, run this, and you will see starts Spark streaming. You should see output something like this. Okay, now we can move on to next tutorial, and that should be much faster because we already done with the setup and everything. So in this tutorial what we are showing is there are two streams coming in and going to two Kafka topics. So there will be a program which will be, in this case we are not connecting to live stream like in Wikipedia connector, we were connecting to a live Wikipedia stream. So the edits as they are happening on Wikipedia, they are being transmitted into our system live. Here this is not a live example. Add and click events are something we just made up and created a file, and then we are just to illustrate a concept. So here there's a program which will read these two files and write it into two topics, add topics and click topics. And then the Spark streaming consumer will read from those two topics and then create the mini batches of whatever time we have specified, and then we will do operate on it. And another, so we'll to have two concepts here, one join, another is how to use the state. So So to start with, you can just go to the CD tutorial and run this program. This will actually take it from, we will rerun it again, but it will read the file and write it to the Kafka topics. And its code is very similar to Wikipedia connector, except that it's not connecting to IRC, just reading directly from file and doing a producer.send to Kafka. This is the simple structure of add event. We took query ID, add ID, and timestamp. Where query ID, you can think of it as a search query, and add ID is the like a CPC based ad shown on a search, a textual ad, text ad on the search. And then this click event, which shows again query ID, click ID, and stamp ID, timestamp, sorry. It's pretty similar. Go to the add event joiner Scala and write add code here. So here, instead of creating one stream, we will do two Kafka utils.create direct stream with two different topics. So we are basically creating two streams. We are doing a join on them. Which will give us query ID. After the join, we'll get query ID. The join is on query ID, and we'll get query ID, and then a tuple of add event and click event. Later on, we'll change the key using map and reduce to add ID, and then do the aggregation. After that, we will use the state to cumulatively add across various RDDs. So try it on your own. It's exactly follows the same kind of path that the previous example did. And raise your hand if you have any questions or want to know anything. Yeah, this is a very simple example just to illustrate the concept. Yeah. So how many people have gotten it working? The second one, the add event joiner. Oh, good. That's pretty good. Yeah, so we definitely write into Kafka one. Second thing, I think you can try out Cassandra or HBase. Yeah. It really depends on your application, and I think, yeah. Yeah, so out of order stream is I think more like a more advanced topic, so I did not cover in this tutorial. Needs a lot more time, but definitely like buffering those things into like a memory, and then something using like RocksDB, like some they use RocksDB, and then waiting for the join and evicting could be one technique, and there are various other techniques. But I think that would be a separate long discussion. Yes.